Hi, my name is Josh Manning. Welcome to Red Hat Partner Connect. Today I'm going over Kubernetes test environment setup. This is the third installment in the operator webinar series. What do you need to develop an operator? Well, the prerequisites are a RHEL host machine. It is required by the Red Hat Container Catalog that all container images published to the third-party ISV registry provided, that they all contain a RHEL-based image, all container images. Next, we'll need a Kubernetes or OpenShift cluster for testing. That is the focus of this presentation, thus the bold lettering there, where we will get started using Minishift. Additionally, to further actually interact with operators and work with them at the code level, you'll need the operator framework, either the Helm App Operator Kit, which allows you to simply develop an operator consuming merely Helm charts, and the Operator SDK for lower level actual code written in Go and provides us low-level Go libraries for that. Additionally, for the Operator SDK, you'll need the actual Go programming environment, and as well as the DEP package management utility for Go, which is the tool used in Go to obtain build dependencies or external packages declared in your code base. The Operator Lifecycle Manager, you can either manually install that using the GitHub repository, github.com/operator-framework. It does require the Helm client, not Tiller. However, it is shunned due to essentially running as root in the cluster. So only the Helm client is required by the OLM. However, probably the simplest way, OLM is being included in OpenShift beginning with 3.11. Getting started with Kubernetes. Obviously, in the presentation, we've already stated that we'll be getting up and running with Minishift, where Minishift is a Kubernetes cluster for local development. That's double quoted because it's not a cluster, it's not a multi-node deployment. It runs as a virtual machine, a single virtual machine. So it's a simplified single node deployment. It acts as both the master and node. It's an easy local offline development model. It does not require any cloud services whatsoever. It is a single binary provided by a TAR archive that you could just download and extract. And there are some other like drivers and things and some other setup to get the virtualization libraries we need. It does support different host OSs and hypervisors. However, today we're fixating on RHEL. It does offer advantages over OC cluster up, namely more tunability with the CPU, RAM, and disk size of the VM that it launches, whereas OC cluster up does not provide that. Minishift also doesn't require Docker be installed on the host machine. We'll begin with setting up the Kubernetes environment. You can follow along using the quick start guide provided at the following link. That is github.com/rhc4tp, and there is an operators repository there. And if you just go down into the docs subdirectory, you'll find the minishift_quickstart.ascii doc file, and all these same commands are provided there for you to easily be able to cut and paste in your own terminal shell. I will start with setting up the virtualization environment, and that is done initially by installing the Docker machine KVM driver. We use curl to go ahead and download that here in the first command, and we'll output that to user local bin. You'll need root in order to do that. And it will be located in user local bin as Docker machine driver KVM with hyphen spacing there. And then we just make the binary executable. Obviously, you'll still need root permissions to make it executable for all users. Setting up the virtualization environment, the actual virtualization libraries. You'll install libvirt and QEMU-KVM packages in RHEL. This will provide all the virtualization libraries you need in order to run Minishift. And we also suggest you run as an unprivileged user. Obviously, running as root is not best practice as far as security is concerned. So in order to do that, you'll need to add yourself to the libvirt group. And then you'll update your current session, which will update your group membership for your current user that is logged into the current session and make that change visible to the shell. And then you will start the libvirt services and enable them at boot up using the systemd system control command, system control start libvirtd, and also system control enable libvirtd. And continuing with actually installing Minishift, here's where we download the Minishift 1.24 tarball for 64-bit Linux systems. It is a pre-built binary encased in a TGZ that we can download directly from GitHub with this command. And then we would just go ahead and use this one-liner here to extract the Minishift binary, which is in a nested folder named after the actual tarball itself. But as version numbers change, to more easily update this guide and make the command more applicable, we've added that asterisk there. We'll mask all first level directory folders within the tar archive. And then we actually strip off that top level directory. And we're extracting that in user local bin there, so it's globally available for all users. And then we can go ahead and launch the Minishift VM, Minishift space start. It will go through and download a CentOS 7 ISO, which is the boot media for the VM. And it will also download the OpenShift client and place that into your home.minishift directory. And also it will download the OpenShift cluster container image and go ahead and initialize that cluster for you. Probably will take about 10 minutes altogether from start to finish, depending obviously on your internet speed there. To actually enable the ability to just type Minishift in a terminal and have it resolved to where the binary is actually located, the eval statement there provides that for you. And that eval actually runs the Minishift command, oc-env, and all that does is print out an export of the path environment variable with the full path to your home directory's .minishift location of the OC binary. Next, we'll enable OC and kubectl system-wide. We start by copying the OC binary from its location and $home. That's just an environment variable which will expand the current user's home directory, whoever you are logged in as. .minishift, we'll extract that into user local bin. You'll see we use the which OC command, which locates the full path of the OC binary as the source file we're copying, and we'll take and place that into user local bin. We prefix that with sudo. That's important to note here, because if you're logged in directly as root when you run this command, you won't be getting the actual .minishift folder that you're intending that you ran as a normal user. Next, we'll create the symlink to OC to actually enable the kubectl alias. You can actually just create a shell alias in bash for this. You don't have to make the symbolic link here, but it's simple and straightforward, and it can be done for all users, and it'll be pretty transparent what you've done to actually enable that command. Well, that wraps it up for today. In the next episode, we'll cover writing Helm Operators. To get started, you need to go to connect.redhat.com, sign up as a Red Hat technology partner, get started, sign up for the free not for resale subscriptions for development, for OpenShift, as well as other technologies we provide. And go ahead and create a container image project in the container zone. That will get you set up with a Docker repository we can push to that we'll need in the next presentation. And then you can check out some of our other resources. We've already shown the Red Hat Connect for Technology Partners GitHub site. There's also a operator-framework Google group you can join and be able to interact with the actual dev community for the operator framework. And there's also a blog site for Red Hat Connect for Technology Partners. But I would like to thank you all for attending today. Looking forward to getting more in depth with operators as we learn about this exciting new technology moving forward. And I'll see you in the next presentation on Helm Operators. Thank you for attending.